Hi everyone. In today's lesson, I'm going to talk about a new type of integration, and it's called integration by use substitution. Okay, let's take a look at our first example. So example number 1. I want to take the integral of 2x squared plus 3 to the fourth times 4x dx. Now, normally how you would solve or go about solving this integration problem is you would technically have to take this whole thing and raise it to the fourth power and then multiply it by 4x. Now, that seems a little bit complicated. I don't want to take this and double distribute twice and then double distribute again, to make it one polynomial so that I can add 1 and divide by that number. So what we can do is something called use substitution. So the first thing you want to do is you want to let u equal the stuff that's inside the parentheses. And then once you do that, you have to find the derivative. So we're going to find du. And then the third step is we're going to solve for dx. So just write down those steps so you have them on the side, and then I'm going to show you what exactly that means. Okay, so we're going to let u equal the stuff that's inside the parentheses. So we're going to let u equal 2x squared plus 3. That's step 1. Step 2 says find du. So du means find the derivative of u. So if I want to find the derivative of 2x squared plus 3, remember derivatives, we take the 2, we multiply it in front, so that becomes 4. And then we subtract the power down by 1, so 4x is fine. And then if I'm talking about taking the derivative of 3, I know the derivative of a constant is 0. So I took the derivative on the left side. The derivative of u is du, so I have to say what I did over here. I took the derivative of 4x, which is respect to x, so I have to write dx next to it. It's like implicit differentiation. Then I need to solve for step 3, solve for dx. So I'm going to divide both sides by 4x, and I have that dx is equal to du over 4x. So now that I have this information, basically this stuff right here was setting us up so that we can solve. So let's go back to our original problem. And I want to integrate u to the fourth. Notice how now I'm putting u in instead because this is 2x to the third plus 3. That's what I let u equal. And I'm going to leave the 4x alone. So we're going to leave it as times 4x. And then technically this is times dx as well. So now I found dx already. dx was du over 4x. So I'm going to put that here. So the idea behind use substitution is that I'm changing the variables from x's to u's, right? So see how this has all x's and then dx? This has a u, an x, and a u. So I can't have two different variables. So what should happen in every single one of these problems is the x's should go away. So notice this top with this bottom cancels nicely. So now I'm integrating u to the fourth times du. So u to the fourth du. Now this is perfect. Everything we have is in terms of u. So now we want to integrate like regular. So like normal, we add 1 to the power, u to the fifth, divided by that power, and then plus c. So then the final answer, all we have to do is put back what we let u equal. So we let u equal 2x squared plus 3. We raise that to the fifth, divided by 5, plus c. This is my final answer. Perfect. Let's try another one. Okay, so we'll call this example number 2. So I want to integrate 4x to the fourth minus 5 to the negative 3 power times 8x to the third with respect to x dx. Again, you can put a multiplication dot there if it's easier for you. So, same kind of concept as before. We're going to let u equal the stuff that's inside the parentheses. So I'll write the steps again. Step 1, let u equal what's inside the parentheses. Step 2, find du. And step 3, solve for dx. All right, so these are going to be our 3 main steps. So again, step 1, u is what's inside the parentheses, 4x to the 4th minus 5. Then I'm going to do step 2, take the derivative. So du is equal to, again, derivative, we take the exponent and multiply it by the number in front. So we should get 16x, drop it down a power, x to the third. And again, the derivative of a constant, this negative 5, is 0. So we always have to say what variable we're taking the derivative with respect to, so we multiply it by dx. And then step 3, solve for dx. Since that's multiplication, we can divide both sides by 16x to the third. So we get dx is equal to du over 16x to the third. Perfect. So now that we have our preliminary information, we have what dx is, right? That's the most important part. I'm going to go back to my original integral and plug stuff back in. So this stuff right here, my 4x to the 4th minus 5, that's my u. So I'm going to make this u to the negative third times 8x to the third times, now I need to substitute dx. Well, this is what dx is equal to. So it's du over 16x to the third. So again, just like before, we can't take the antiderivative with u's and x's. It has to be one single variable. So these x's should cancel, and in fact they do, right? Because any top with any bottom cancels. But this one's a little different because the 8 and the 16 don't cancel. But 8 divided by 16 is actually 1/2. So we can go ahead and make this the integral of 1/2 u to the negative 3 times du. So basically I just divided this 8 and 16 and just threw it in front. And another trick for integration, anytime we have a constant, this 1/2, we can pull it on the outside and write it as 1/2 times the integral of u to the negative 3 du. And now this is just like normal. Add 1 to the power, right, and divide by that power. But just remember, when you're adding 1 to a negative power, it actually becomes smaller. So it's u to the negative 2 over negative 2 plus c. And then this 1/2 that's in front would just simply be multiplied. Okay, so then our final answer is going to be, we're going to multiply these fractions, tops with tops. So I'm just going to go up here. 1 over negative 4, u to the negative 2 plus c. So I can just substitute the u back in. So I'm going to make this negative 1/4. U is 4x to the 4th minus 5 to the negative 2 plus c. So that is my final answer. Okay, just in case I give you a multiple choice question, I want to show you the different ways that you can write that answer. So we have negative 1/4, 4x to the 4th minus 5 to the negative 2 plus c. So I want you to understand that you could actually write this as your numerator since it's multiplied by negative 1. So you could make this technically negative 4x to the 4th minus 5 to the negative 2 power all over 4 plus c. That's another way. Now there's one more way that you could make this. Since you have a negative exponent here, you technically could bring that negative exponent downstairs. So your other final answer could be negative 1 over 4 times 4x to the 4th minus 5 squared plus C. So here are 3 different ways, 1, 2, and 3, that you could write that final answer. Now, if I'm asking you an extended response, I will accept either one of these answers, but if it's a multiple choice, you have to understand that the answer could be written in one of these 3 ways. Okay, let's try one more example for today. Okay, so this time I'm going to give you a fraction. So this will be example number 3. So we want to integrate 24x to the third over 2x to the fourth minus 5 to the fourth power dx. So same concept as before. You take the stuff that's inside the parentheses and you make that u. So I'm going to do that over here. U is equal to 2x to the fourth minus 5. And then we're going to take the derivative, so du, which is 8x to the third dx. And then again, solve for dx. So divide by 8x to the third. So dx is du over 8x to the third. So let's go back now to our integration and plug what we know back in. So we know 24x to the third over u to the fourth, right? That's what u is. And now what's dx? Well, I just found it. So dx is du over 8x to the third. And again, the x to the thirds should cancel, which they do. And 24 divided by 8, right? I have a 24 on top, an 8 on the bottom. Those divide out to 3. So it's 3 over u to the fourth du. But I can't integrate with a fraction. So I need to take this exponent and bring it upstairs. So this is now the integration of 3u to the negative 4 du. Now you can integrate with this 3 that's here, right? Add 1 to the power and divide by that power and just have the 3 in front. Or you could do what I did in the last example and take this coefficient, bring it on the outside. So it's 3 times the integration of u to the negative 4 du. So if I go up here to finish it, when I integrate u to the negative 4, remember I'm adding 1 to the power. So u to the negative 3 divided by negative 3 plus c. And then don't forget that 3 that I had in front. Now you're going to notice that this 3 and this negative 3 actually cancel, so that's fun. So these go away. So it's technically u to the negative 3 over negative 1. But when I divide by negative 1, that's really the same thing as putting the negative in front. So I can make it negative u to the negative 3 plus c. And then last but not least, put u back in. And this is my final answer. And again, remember the other ways that you could write it. Technically, I could take this negative exponent and bring it downstairs. That's an option as well, and make it positive. Okay, that's it for today. If you have any questions, please let me know. All right, have a good one.